Hello and welcome to Dare to Know, interviews with quality and reliability thought leaders. I'm Tim Rogers, and today we have a special interview recorded by Fred Schenkelberg in January 2016 at the RAMS conference in Orlando, Florida. Fred's guest for this interview was Les Warrington, Principal Consultant at Ops a la Carte LLC. Les has been dedicated to reliability and its benefits for over 30 years, working in a variety of roles as a designer, manager, researcher, academic, trainer, and consultant. His experience includes 18 years with the Royal Air Force in the UK, senior fellow at the University of Warwick, and director of reliability at Research in Motion. Les has jointly developed and delivered a highly successful Quality and Reliability Masters of Science program. His work has included delivery of high-technology products under challenging circumstances, minimizing customer risk through novel assurance and warranty programs, and generally applying reliability methods to a wide range of problems. For further information, please go to www.lwcreliability.com. Fred talked with Les about his consulting work and his range of experience in the military, academia, and industry. Let's join Fred's interview with Les Warrington.
All right, welcome to Dare to Know. This is Fred Schenkelberg, and I'm sitting down with a longtime friend of mine, actually, Les Warrington. Les?
Hi. Hi, Fred.
All right, so we're at RAMS, and there's going to be a little bit of background noise. I think we're going to hit the end of a session here, so we might get some traffic, so bear with us. But Les, I don't know, you asked me at the start, what are we going to talk about?
Yeah.
And I think I listed like 3 careers and a variety of different activities and things you did. Let me ask the starting question, though, is you've run programs, you've taught in university, you're consulting, you've written papers and presented, you've done all kinds of different projects and work, you teach. Even today, you're still teaching the CRE prep course kind of thing. How did you get started in reliability engineering?
Okay, I didn't have a choice.
So it was ordained or something that thou shalt become a reliability engineer?
I was an engineer in the Royal Air Force in Britain, and they manage your career.
That's true.
It's supposed to be, develop your career. So you have different work experiences from being in charge of all the maintenance and flight safety for a squadron of aircraft,
right.
To have management positions, and one career move was to a little team that was responsible for doing reliability analysis to make recommendations for requirements for future projects.
Okay.
And so there were 2 officers and 4 senior non-commissioned engineers, and we were it. And so we learned on the job, we went on courses,
right.
And gradually honed our skills. So we were influencing the future of the Royal Air Force. And I moved into a second position which was in procurement, in the Ministry of Defence, where I was then working with industry in the future of the military equipment.
Well, I often go to the Ministry of Defense standards concerning reliability. My favorite is the reliability case.
Yes.
Are you familiar?
That was the era, and so that was one of the things we developed.
Okay. And so I'm going to pursue that a little bit. It's completely, I didn't realize you were involved or were in that time frame when those things were being developed. But when you're working with a supplier or a vendor or contractor, and we often give them a set of requirements. We said, make it this big, this color, this size, we want it to last this long, things like that. Yet the ability, we're expecting them to design to meet the reliability requirements and just do it. And sometimes we use demonstration tests or other do this test and then we know it's good. And that's not always possible.
No, that's right. And I'll say instigated a move away from that, and recognizing that the more reliable a product is, the more expensive a demonstration test would be.
Oh, certainly.
So you're spending more with less risk, and so that's counterintuitive. And so we started to seek more open and and allow more innovation in that management of risk.
Right.
On one of the cases, we wanted to, we were procuring new transportation vehicles to move not cargo containers, but flatbed, which anything could be loaded on, and it'd be offloaded in the field. Essentially, they were commercial style vehicles that would do a lot of road driving,
right.
and so we explored the opportunity to integrate into that road network of support of vehicles on the road. So if they broke down on the road, the local AAA comes out. The local garage goes out to recover it, and so the supplier was willing to take on the financial risk of that. So there's motivation to him. We could integrate into an existing system, which was pan-European, that could minimize our risk.
Right.
And so that was the way in which we, at the end of the day, limited the risk. There were other aspects, within the reliability case that would be in project, but we needed something at the end that would say, okay, and put your money where your mouth is.
That's right, and that's a key part to it. Is I've run into a few military contracting type organizations that they only made money on the repairs, so there was a counter incentive to making it reliable.
Yeah,
and it's like I never quite understood military procurement, and maybe that's why I've enjoyed the ones in the Ministry of Defense, because it was basically the notion I really liked was there's a lot of ways things are going to fail. We're not going to get it to not fail.
No.
It's just a matter of, do they understand where the risks are, and is it mitigated appropriately? And then what's the next thing to expect to fail? And so one way I've seen it implemented is you just basically ask the vendor what's going to fail.
Yeah.
And how do you know?
We need to leverage that knowledge, that skill set that a good vendor has. We also need to look at, okay, what is his incentive? Because if, like you say, it's his incentive to have more failures because it's more repair business, that's the wrong way around. But we also mustn't be dogmatic about it. You want a good relationship with your vendors.
That's right. And so the reliability case, that whole structure allows you to enter a conversation, rather than do this and it's a pass-fail and it's high risk for all parties involved. And then you can start early in the program and start exploring where the risks are.
And there is no difference between that and the commercial world.
That's right.
That every project is working to balance the performance, the cost, the time scale, all the functionality, the business, the profit. It's trying to get the best package into the marketplace.
That's right.
And so within the company, you're also having that conversation.
Or should be.
And it should be. That's right. In my own consulting business, I have on my website that front and center. I don't want reliability. It's the benefits I want.
That's right. That's right.
It's the benefits that reliability brings. So if you can bring that ethos into a company, design engineers can understand that.
Right.
The project manager can understand that. The finance director can understand that. And so, each party may be concentrating on one aspect of the benefits, and obviously a good company will balance those benefits. But your ability to sell reliability within the company and get the buy-in from the teams is by how well you can sell the benefits and show the benefits.
That's right.
And bring the customer. What's going to make our user, our end customer, what makes them tick?
That's right.
And bring that into the requirements. And one of the companies that when I started working with them, it's a long-term relationship I have, which I like long-term relationships. That their requirement when I started working with the company was MTBF. And I know that what Fred Schenkelberger likes about MTBF, but what to change from it now? Product life was certainly one of them that I asked, and they agreed that I could talk directly to their customers to start to get to understand them. And certainly product life was important because that affected their return on investment.
That's right.
Very strongly.
Right.
But in addition to that, on the, should we say, the ongoing running costs, it's the emergency call out to go and fix it. That's what was hurting them. And so, well, why not describe the reliability requirement in terms of that?
Right.
Why make it as a probability of failure? Okay. So we expressed it as no more than one unplanned maintenance event per system per year. And internally we said that we would do that with 90% of systems, 90% confidence.
Okay. I've heard that described as the number of truck rolls, where you have to put technicians in trucks and roll.
Yeah. And that, because it's so easily understandable as being what makes the customer tick,
right,
that has been bought into within the company. All the project managers, the design engineers, they understand it. They can work for it. Now,
you can also visualize that.
Yeah.
98% probable of success over 2 years is harder to visualize.
Yeah,
definitely.
And so within the reliability team, we've got the math modelling to translate, to take a viable distribution or a log normal distribution, or if it is an MTBF, translate that into what effect that is.
Number of events per year.
Yeah, that's right. Yeah.
And then, but that thing can be applied by what's your installed base, but it also applies to the single customers. How many events they should expect that year.
Yeah.
It also is at a point where you're really looking at uptime and the small probabilities of happening. So those tend to get harder to visualize and internalize as the designers.
That's right. Oh, when you start looking at, okay, on what level of reliability does that require of that component over the X years at life, and it comes out to be 99.9999%.
And then we go back to, if you're going to do a demonstration, you need tens of thousands of units and all this extensive stress or amazing acceleration factors, and like you said, it just goes up exponentially with the cost of proving that.
Yeah.
Whereas getting back to fundamental understanding of the risks and format, and so it ties right back into that. So in the consulting, I'm sure you've walked into teams that were resistant to improving reliability. They may understand that they needed to, right? They may have customer feedback, or their boss said, we got to fix reliability or whatever. But I mean, you've seen teams that may not. How do you approach an engagement where the hurdle is the buy-in or the understanding?
Coming from their perspective, that get to understand them, what's making them tick.
Goes back to that what's in it for me, or what's in it for them, I should say, what's in it for them kind of approach.
And with engineers, the thing that I find makes them tick is they want to design a good product.
That's right.
That's why they're design engineers, because they want to design a good product. So look at it. How can I help you? So you don't come at it with a requirement
That's right. Or here's all the things that are wrong with your product.
That's
with
right.
no solutions.
Yeah,
for it.
that's right.
Yeah.
Take facilitating or working with teams with FMEA.
Right. Let's prioritize and focus on the ones that can actually, if you make this change, we can see a benefit.
Let's step back before then. I've had more success with design teams by, first of all, looking at what is the functionality that's needed,
right,
and writing that down,
right,
and facilitating getting out the nuance, the limits of that functional requirement, and the list of those things. And then you start looking at, well, how can it fail? And keeping it simple at that point it's the non-achievement of that. So
that's right.
If it's supposed to do something, then you can not do it. You can partially do it. You can do it too soon, do it too late. So
that's right. Too slow.
Not nice and simple. But just by doing that, they realise that, hey, they haven't quite captured all the essence of the functionality. So that is a design aid for them. Yeah.
That really is. Yes.
It's a design aid.
Yeah.
So you then bring them with you, and then start looking at the mechanisms and by then usually they're running with it, and I'm thinking of one project which was a startup company. The project manager took ownership of all the actions, to managing the actions from that FMEA. That product was a great commercial success. It was a consumer product. It was pitched at about the $150 level. It was high tech, obviously it's a startup, but so successfully that the emergency services saw the benefit of it, the military have seen the benefit from it, and so it's now been onward developed to further optimize it for that kind of environment.
Those environments, right.
And that started with an FMEA.
Wow.
And bringing them on board, they appreciated. The project manager realised just how much benefit that there is in it, and they ran with it.
Yeah, the project managers have a lot of influence on how their programs are run, and you can see if it's a reliability plan that's kept separate from the project plan that they're managing, the chance of success is lower, or nil almost. Yes. And if it's integrated into it and it's part of the discussion, it's part of the routine, and eventually, I mean, I'm sure you've seen it where then it gets integrated, where it's not even considered a separate activity or whatever. Yeah. But you can do that starting with just an FMEA. Get the discussion going.
Yeah, that's right. Companies, as your skill set develops, so you'll grow. But you don't start castigating people because they haven't got the PhD level techniques.
Well, I abuse people because they use MTBF, but that's just me. That's just me.
And I appreciate that. I used to work at RIM, and when I joined RIM, they already had in place very clear and strict quality criteria to launch the product to called validate, but it was the quality assurance of the product before it was launched. And so the defined thermal cycling test, defined humidity test, defined drop impact test. And on cell phones, the drop impact test is a multifaceted but very aggressive
You showed me
test.
a tumbler once that it was like repeated hundreds and hundreds and hundreds of times.
Yeah, and that is not as aggressive as dropping it onto concrete. It takes multiple cycles in the tumbler to get to failure. But what it's doing is it's giving a high impulse mechanical shock that will ripple through the device, and so that is giving you a lot of mechanical integrity knowledge, as well as the finesse of have you spaced the components well. But anyway, for mechanical engineers, they were very much into, and were continuing to develop some very good finite element models to model it, and they were wanting to verify that against testing. But because we were hand dropping them on the floor,
right.
we're introducing a lot of variability.
Okay.
But that's right. The mechanical engineers, they wanted repeatability so that they knew exactly what they were designing, design iteration, to get a consistent feedback.
Right.
So we had two different objectives, but and I'm kind of lost why I came to this. But the aspect of of that validation, I saw as trying to bring in a good degree of variability, which has less maths associated with it.
That's right.
But it was to try and replicate the outside environment rather than the internal test environment.
Well, the customers don't use our products or your cell phones according to some known script or test algorithm. They don't pick it up and push the buttons on schedule or any of those things. And there is a lot of variability, different types of users. I asked this question the other day to somebody, and I was asking, what's the best way to test a consumer product? And he says, give it to my 15-year-old daughter.
Yeah.
It's just...
Yeah, that's right, yeah. Oh, it's interesting. I think I was sent a prototype product. It was going to be a home consumable product for evaluation, and I wanted to take it apart so I could look at its internal construction. Right. But it was strongly snapped together, and I couldn't, press in the right place to.
That's right.
But I looked at its external design and realized, well, if I drop it that way, it should pop apart, and it did.
So you've dropped a few things in your career. Okay. So what would be the most interesting test or validation you've been asked to participate in? Or have you ever got to shoot at something? No,
I don't, and none of my projects have been shot
test.
off. No,
I think I've done just about everything in Mill Handbook 810, except the ballistic shock. Yeah. And I did get invited to test some flak jackets, and it was a chance to shoot at them, and the schedule didn't work out, so I come this close. But if you had any difficult things to evaluate, because one of the things you were mentioning is get the testing to include that variability of the actual use. Like button testing. A lot of times we set up a pneumatic cylinder that just pushes it back and forth and is very repeated.
For validation, no way.
It'll get to 1 million cycles real fast, yet does it really tell us something?
I mean, again, going back to RIM, for the insertion testing of all the connectors, which I've replaced my lightning connector on my iPhone twice. Give me a screwdriver, I can take anything apart. We came up with a script for people to actually do the insertion.
And it was different people
in different people, different ways. But so many insertions with your right hand, so many insertions with your left hand.
Take a break, hand it to the next person.
So many insertions with your eyes closed.
Yeah.
So because I'm short-sighted, so in half light, I can't tell whether the connector's the right way up or not.
That's right. Well, I have the habit of I'll have the cell phone or something. I'm reading something on my iPad, and then I turn off all the lights, and I need to plug that in. So that's a real scenario.
Yeah. But I do enjoy designing tests in conjunction with the design engineers, because often we're exploring a potential interaction with the actual operational loading of the unit. So with this particular industrial electrical motor, that we knew that in terms of its installation, the controller was going to be a number of 100 feet away from the motor.
Right.
So you've got a good degree of capacitance and kind of issue with the cable length.
The parasitic.
Parasitics.
Parasitics.
That's right. And so how to incorporate that into an accelerated with thermal acceleration and with load acceleration, and with the electrical stimulus. That was quite an interesting development. How could you develop to design a test box that would simulate that 100 feet of cable.
Yeah, and get a long room.
That's right. Yeah, so that was great. So I enjoyed doing that one. Another one was with it was another electrical motor, totally different application, but the MOSFETs for the brushless motor
drive. Yeah.
That we knew. Everyone knows that MOSFETs don't like power spikes.
No.
And yet this duty cycle is on off on off on off. So it's got a lot of that. And in different environments. So how are we going to integrate that and coming up with a DOE on that one? And that one again was designed. It was the discussion and the evolution of how the DOE and the reliability testing would help the design engineer. Was a major part of it, and the design engineer was very much on board that he wanted that test. It became his test, and yet it really was a reliability test.
And to to a large extent, that's where it really should be. Is we're there to help coach and guide and help spot risks that we're familiar with.
Yep.
But they're going to have to make the decision. What's the right path forward? So if they're going to design them experiments, it's a tool that helps them make better decisions, to gather the appropriate data, all those things. Now, I think we could swap stories for quite a while longer.
Oh, we could, yeah.
So, for the audience, you're in consulting now and staying busy, doing some teaching and a variety of different things. What's the best way for people to get in touch with you?
Well, I've got my own website, which has my contact information. So
okay. And I think I have your card. I'll probably track it down there and add it to the show notes.
Yep, it's lwcreliability.com.
LWC.
Les Warrington Consulting Reliability, so just lwcreliability.com.
Okay. Right.
As my website says, that I'm a dual national Canadian and UK. So until Brexit, I can work anywhere in Europe with no problem. How it will pan out after that, I don't know. Can work in North America with either Canadian or the TN visa, and I've done teaching around the world. One passport or other will get me into countries, So I enjoy. People ask me, what industries do you have expertise in? Really, the answer is what industries can I help?
That's right.
And I know that every industry that I've called upon has been beneficial to the company, and I have to say beneficial to me as well. I enjoy it. I enjoy the continual learning of technology, the application of the reliability methods, be it at the detailed technical design level, test planning, corporate strategy. Fred, you were involved to a degree. IEEE 1624. I love that standard as being a condensed framework to identify and justify to companies. This is where you can improve, and this is what you can do to improve.
Yeah, and that's the reliability program assessment.
Yes, that's right. Yeah,
that's right. Yeah. I know where that is. I can add that to the show notes too.
Yeah.
So, one last question is for the folks that are entering reliability engineering, and there's a good number of them here at the conference. What one piece of advice would you give them as they're looking ahead at their career or they're getting started? What should they focus on or get started doing?
I think it comes back to that motto that about it's not reliability one, it's the benefits. And so as you're learning techniques, it's what's the benefit of that technique? How does it contribute to the company? How does it contribute to the product development? Any reliability activity, it has a place within the project timeline. It has a need for input from people,
right.
and it's delivering an output to help somebody. So if you don't recognize who you're going to be helping, when they need that help, how you can best help them,
Right.
then you've lost what reliability engineering is about.
That's right. That's right. Oh, that's excellent advice. Yeah, that's perfect. Well, so thanks so much, Les, for sitting down with me for a few minutes, and we got through some of the background noise, and now, of course, we're ending, and it's really quiet. So we'll have to talk some more, because I'm just biting at the bit here.
Yeah.
We're up close to 25 minutes or so I'll wrap it up.
Yeah.
So thanks a lot, Les. I sure
Thank you,
appreciate
Fred.
it.
Yeah.